biggest thing with this is we have two different ways of doing it. We have general solutions and specific solutions. There's no difference in the way you solve the problem. It's just a difference in the way you write your answer. All right, so we treat these again. Sine is just, it's like square roots or logarithm or anything else. You get it by itself first, and then you get rid of that part of it. So just like when we had square roots, we got the square root by itself, then we squared both sides to get rid of the square root. So this is the same thing. We get the sine by itself first. So we divide by 2. Then we get rid of the sine. Now, the way we get rid of the sine is technically we do this. Okay, but we're not going to really be doing that. What we're going to be doing is we're going to be looking at our unit circles. Now, since we want a general solution, yeah. So back to this, this thing. Okay. Now, since I want the general solution, what I want to know is every place on this unit circle where sine equals 1/2. So I'm going to ignore this. This is technically how we're doing it, but I'm going to kind of ignore that. What I want to do is I want to know every place on here where sine equals 1/2. Remember, sine value is actually the y value on the unit circle. So let's see. It equals here at pi over 6. Where else does it equal 1/2? 5 pi over 6. And what I do is I just make a list of all the places on the unit circle where it equals. And I put them inside of a set of parentheses. Okay, any place else? Well, all of them down here are negative, so that's not going to work. So that's every place. Now, remember our sine graph, if we were thinking about the graph, the sine graph goes on forever. Our unit circle goes around forever. So I would keep hitting these 1/2 marks every single time I go around the circle. So I have pi over 6, 5 pi over 6. But if I keep going around the circle, I would also have 13 pi over 6. And then I would have 17 pi over 6. And I keep going. I would have then 25 pi over 6. And 29 pi over 6. And I could keep going. And it just keep going on forever, right? So I want to show the fact that this goes on forever as my general solution. So the way I do that is I write it like this. I'd say plus or minus 2 pi n. Where n equals 1, 2, 3, and so on. Now, these are my natural numbers in could also write it like that. Natural numbers are represented by the n like that.
What does n mean?
Which n? Little n, big N. Little n, I'm defining little n. It's just a variable. So I'm defining little n as natural numbers. So 1, 2, 3, 4. Now, actually, I want it to be the whole numbers. I want 0 in there too, don't I? So that technically wouldn't be correct.
Wasn't it equal?
So that, I get to choose what n equals, depending on which solutions I want at the time.
So what is the W? What's for all them? W symbol?
There isn't one. Now that we define what n is, what we're going to do is we're going to skip on defining it every single time. We're just going to write this. So I'm not going to make you write this every time you write out a general solution. Just as long as we understand anytime we write this in from here on out, it means this. Okay, now, anytime we want a specific solution is going to be defined on some sort of range. Or domain. Sorry, it's going to be a domain. Find a solution on the domain of 0 to 2 pi. So that's our unit circle, correct? So what are the solutions on our unit circle? Pi over 6 and 5 pi over 6. So it's just the solutions without the 2 pi n.
What's the 2 by n?
The 2 pi n just tells us that our solutions go on forever. So the 2 pi n is just our unit circle.
How do we know they're not forever?
Because whenever I'm doing this, I can keep going around the circle and keep finding more and more solutions. Because I want to know every place where sine equals 1/2.
Can't equal -1/2?
Yep, and that's why I can do minus also.
Okay, cool.
So this just tells me I can find anything by plugging in a number. And I can do plus or minus. So I can find a solution by doing minus 2 pi times 2. That'll give me another set of solutions. Okay, that makes sense? Okay, so this is how we do solutions, depending on which kind of solutions they ask for. So we're going to spend the rest of the time on solving equations. Okay, so anytime they want a general solution, what they're going to do is they're just going to give you an equation and tell you to solve it. If they do not ask for a specific solution, then they're asking for a general solution. If they are asking for a specific solution, they will state it. They have to state it if they're asking for a specific one. If they don't state anything, like on this one, then you are required to give the general solution. Okay, so I'm solving this one. Again, we just have to get the cosine by itself. So I'm going to start by distributing. And we're going to hope that I set this one up right. Okay, so I'm going to move the cosine squared over here.
Wait, so on this one you can move it over?
Yeah, because we're solving equations.
Oh.
We're not verifying. Okay, now I need to square root it, correct? Okay, whenever I square root it, what do I have to do? So it's going to be this, but if I just did that, I'm going to get a wrong answer. What am I missing? Plus or minus? Anytime you square root a problem, you have to do plus or minus.
just the first logarithm.
Okay, so I want to go around my circle and find every place where cosine is a positive or a negative square root of 3 over 2. Helps if I turn my paper correctly. So it looks like all the pi over 6's. Every single pi over 6 gives me either a positive or a negative square root of 3 over 2. It's going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.
Zero plus. Oh.
Uh-huh. Yep. So cosine is the x values in the ordered pairs. So I go around and I look for all the ordered pairs where the x value is either a positive or a negative square root of 3 over 2. So that'd be here, 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 and here. So I take all those angle values. And unless they tell you specifically, we're just going to use radians for everything. Because I know on all the specific ones they're going to ask for radians, so on all the general ones we're just going to use radians also. Okay, we're going to solve in the specific, for specific solutions from 0 to 2 pi. Okay, what should I do with this?
Distribute.
Nope.
Use a container.
Nope. Nope. It's already factored for us. Wherever you have factors that are equal to 0, you set each factor equal to 0 and you solve. Right? If I had an equation that was factored with x's and I had factors like this, how would I solve that for x? I take each factor and set equal to 0. So if you multiplied it together, you would end up just having to refactor it. Okay, so when does secant of x equal 0? Oh, remember, secant is cosine flipped over, correct? So what you're doing is you're looking at the x values, but you want 1 over the x value. So when can I take the x value and put it underneath 1 and get 0? Wait. If it was pi, that'd be 1 over negative 1. That's negative 1. Pi over 2, that's 1 over 0. That doesn't equal 0. I know it's been a while, but think about the graph of that. The graph of this looks like this.
So 1 over 0 is the constant.
Yeah, because if you're thinking about it with cosine, wouldn't it be 1 over 0?
Yep.
Okay.
The graph looks like this. The graph never touched the x-axis. It never equals 0. So it's not possible. So there are times you will get some that it may not be possible. That's fine. Okay, well, how about this one? When does secant of x equal negative 1. So when does 1 over the x value equal negative 1? Pi. Right? 1 over negative 1 would equal negative 1. That is the only time on the unit circle. We only have to do the unit circle because we were asked for a specific solution.
What's the x plus 2 and x plus 3 thing in the formula?
Oh, I was just showing you, whenever we have factored, we do this. So having the secants doesn't change it. So it doesn't actually have anything to do with our problem. Yep.
So how do you know that the second x equals negative 1 is pi? Because I thought sec was I thought that's cosine.
It is. It is cosine. It's 1 over cosine, right?
Yes.
So cosine are the x values, correct? So this right here would be the x value. So in order to get negative 1, I'd have to have 1 over negative 1. That'd be the only place where I could get that. So that's why it's pi. So some of them are going to take a little thought. Like, where does secant of x equal 2? Secant of x equals 2 at pi over 3 and 5 pi over 3. Because secant of x means you flip them over. Now wait until you get to tangents and stuff. Okay. How about that? How are we going to solve that?
We're gonna square it. I mean, square root it.
No.
We're gonna subtract.
We don't want to divide because what happens if sine is 0? And so we don't know if sine is 0.
What we're gonna do is you're gonna subtract something and do a factorial and get 1.
Yes. I'm going to use Pythagorean. Doesn't matter which one you change. I'm just, I randomly chose sine. I could have changed cosine. Either way, the answer will come out to be correct. The reason why we don't divide is because whenever we divide, we assume that sine does not equal 0. Or cosine if we divide by cosine. Whenever we assume something, then we're eliminating the possibility of those answers. If you eliminate the possibility of answers, then you may end up getting not incorrect answers, but not all of the answers. Because as soon as you eliminate the possibility of answers, if those are supposed to be answers, then you're not going to get them. All right, so let's go ahead and finish this.
Can you add cosine squared to either side?
Yep. Then we divide by the 2. Okay, so I square root. Yep. So whenever I square root, I would get this, but I don't want to leave it in that form. So you have to simplify that, which would give you this. So you're going to get practice with simplifying your square roots. Okay, so I want to find all the places where cosine would be equal to radical 2 over 2. Positive or negative. That's going to be all your pi over 4s. Yep. What's the square root of 1? What?
Because
For
it's
this?
square root of 2 over square root of 2 times 1 over square root of 2.
When
you
it's
get
like,
square root of 2
it's
on top of it.
the triple one or whatever. So like, would it be, isn't it negative positive negative, or is it negative negative positive? That's your call.
You have to rationalize the denominator, which means you take it times radical 2 over radical 2.
Quick question. Is it like, is it negative positive negative and negative triple, is it positive? Or no, is it negative negative positive?
Negative, positive, positive. This one's always positive.
Oh, okay.
The first two signs are the only two that alternate.
Okay.
Okay. Okay, and all these are going to be general solutions, so you need to make sure you put the plus or minus 2 pi in on them.